So this is the homework 5 review session. Alright, let's go to the first one. First one is Monty Hall problem, which Dr. Hobbs already talked in class for a couple of times. I'm just reminder you guys like on the part B of this problem, you'll have to use the Bayes laws, which is well, I mean, you guys can find the equation by yourself during the in the lecture note. And the second question is pretty easy. It's like really simple probability calculations. I think I'm gonna just skip on that one. And let's go to number 3. Number 3 is actually a little bit tricky because we don't talk too much about the covariance and also correlations between like in class. So here's the equations for the covariance. So you have to use like expected value of x and y, and also each of expected value for x and y. For the correlation equations, you can find in the lecture notes. So, but anyways, I also listed the equations for you guys. So you will have to get the variance value before you get the correlation value. So yeah. And let's move on to question 4. In question 4, you will still have used the Bayes law, which is, anyways, I won't tell you about this. And but first of all, you will have to calculate the probability of test negative under disease present, and also the disease absent. Also the probability of test negative under the disease absent. After that, you will flip the decision tree, which you will make the positive and negative as your first decision node, and then you make your second as absent and also present. And for example, you will have to calculate each probability after you flip the decision tree. So here's an example for the positive. For the positive probability of positive, and that's the only example I can provide to you guys, because it's pretty much I pretty much tell you like everything about this question. Alright, let's move to number 5. Number 5 is also a simple probability calculations. I think you can figure it out. Yeah, just let me know if you're stuck somewhere, because it's pretty easy. I think you can finish this question in like 10 minutes. Let's move on to number 6. Number 6 is a little bit tricky. It's about exponential distribution. So in the first part, I think you can definitely found the expect value of x in lecture notes. So I won't tell you too much about this. And for the part B, there's also a equation under the exponential distribution part of the lecture notes, and you can definitely find the equation about the FE, the probability of this in the lecture notes. It will help you a lot, and you can use that for calculating px minus 50 and also px minus 100, and then you will use integral to calculate the p probability in between in between 50 and 100. By the way, this is both of these are smaller or equal. I don't know how to type it in my computer, so I'm sorry. But anyways, you will still use the same equation from here. It's just an integral of the this equation. All right, let's move on to number 7. I feel that both A and B part is a little bit tricky because we didn't have that in class during the lecture. So you can definitely Google the z-score calculator, which you can just use for the probabilities, because you will have to use a if I remember correctly, you will have to use a normal distribution, so you will have to calculate the z first, then you will get a probability of z smaller something, and then you will use the z-score calculator to find the real probability. So the computer will gonna tell you are not gonna calculate the probability of z by yourself. So after that, part C. Part C, I just want to tell you guys this LOIP, which stands for loss of load probability. This is the equation for that. And you may have to calculate P0 all the way from P0 to P5, which is like 6 in total. Oh, good. By the way, this is for the part 3, my bad. Yeah, after this, for the part 4 of this question, you will also have to calculate 1500 million watt. So, and again, you will have to use the PZ bigger or smaller than something and get the real number of this. Then you will have to do for 1500, you will do 3000, you will do 4500 for, and 6000 and also 7500. So 1 2 3 4 5 is gonna be 5 in total. Then after that, you will use this LOLP equation to calculate the loss of load probability, so which is overall probability. One thing I just wanna remind you guys is probability of demand is greater than 0 equal to 1, because you have to at least one generator running. Alright, let's move to the last question. The last one is Poisson distribution. I'm pretty sure you can find this equation in your lecture notes, but just remember this little guy right here, m, is your lambda, which is equal to 1. And then after that, you can get all your p k equal to 0 and all the way to 5. And then for the rest of the questions, you will just do a compare. I suggest you to build a table to compare the 7C, which is gonna make your homework easier to see and make yourself clear about the homework. And then, yeah, I think that's probably everything for the homework review. If you guys have any questions, please just email me anytime, and I will try to get you back as soon as possible. And yeah, thanks.